All right, so based on the request that I got from seventh period, I'm making a video here to show you how to calculate means and standard deviations and graph them with Mac with the Mac version of Excel. What I have open here is Excel on my Mac. I've got data for before and after. Again, it's made up data. And I'm going to go ahead and go through this process to show you what you need to do to run the functions you need to calculate means and standard deviation. So click on the cell I want the mean in for the before column, click on FX, double click average. That's not the data I want, so I'm going to make sure I've got those selected and pick my new data points, hit enter, and I got my 13.0. And then as a shortcut, I'm going to make sure I got my crosshairs over here in the bottom, in this little blue square in the bottom right corner, so it's a black set of crosshairs. Pull that over. It pulls the same function but for the next column, so I see that my average is 60.8. My standard deviations, I'm going to double click standard deviate STDEV and my first data set, hit enter, and I'm just going to pull over again, and it's going to do the same thing for this next data set. But that only works if you have the same number of data points but in the two columns. If you had, and that makes sense for this data set because I have something before and after, but if you're comparing two different sets of individuals, you may not have the same number. So you want to be careful about that little trick there in Excel. Anyways, I've got my data. Notice that these are all in whole numbers. The raw data is all in whole numbers. My process data goes one more decimal place beyond that. But if it doesn't automatically do that, select all of your cells, go to Format, Cells, and wait. Go to Number, and then decide on how many decimal places you need. Basically, if your raw data is as precise as it can be, you add one more decimal place to your process data. In other words, if you have, think of this example, if you got a data point that's you measure as 1 and another data point you measure as 2, the average would be 1.5. If we kept the decimal places the same, then you'd have to round that 1.5 up to 2, which is actually quite misleading about the average. So we go one decimal place further than the raw data. So in this case, we go one decimal place. So that's what I set here. You can set it to 2. I'm going to set it, make sure it's at 1, and click OK. And that should reformat this if it's not already set at one decimal place. I'm going to close this. I'm going to insert a chart. So I'm going to select these 6 cells. I selected chart, go to column, and I want the clustered column. And I don't need this title, this legend there, but if you go to chart layout, here are all the options for the chart title, so you can put in your nice descriptive title up there. You could label your axis, your horizontal and vertical axis with titles and units and uncertainties. We don't need a legend in this case. You don't need data labels. You actually don't need a data table there. And there's some other things you can do with the axes, specific things with the axes and the grid lines. You can add a trend line if your data represents a continuum, but this set doesn't, and what we've been doing so far in class is not. So we don't worry about the trend line. But here is the error bars. If you click on error bars, go to error bar options. Notice this says error bars with standard deviation. Do not, I repeat, do not click on that one. It messes it up, so go to error bar options. I'm going to scoot this table over so I can still see these two data points, 6.5 and 25.4 underneath, because I'll have to select those in a second. I don't want a fixed value because look at what the fixed value does. It gives me the same standard deviation for before and after on the graph, and knowing those values of 6.5 and 25.4, there's a big difference. So they should not look the same. What this is doing, in fact, is adding 10 points plus or minus to that fixed value, which may be important if we were to add error bars to, let's say, uncertainty. But this is not uncertainty. We're adding error bars to represent standard deviation. So And you don't want standard deviation of 1. That's, I'll tell you, let's neglect that because that's going to be confusing. We do want plus and minus, so we pick both. And we want caps to help us see where the plus or minus 1 standard deviation ends. So click on custom and specify value. And here we got positive value. So this is the plus standard deviation. So if our standard deviation is 6.5, that's 1 standard deviation above the mean. We want that, and I'm going to click over. So I have 2 cells. I'm going to have cell E3 and F3 in this case, and I want those values to be subtracted from their respective means. So doing that as well. Excel is smart enough to know that this 6.5 is associated with the mean of 13.0, and the 25.4 standard deviation is associated with 60.8. Now I hit OK, and what we see, and then move this back over and click OK, I see different standard the error bars are different sizes. And eyeballing this, we know 25.4 is bigger than 6.5, so we know that the after standard deviation is much larger than before. But knowing that these values don't overlap, this would imply likely statistical significant, or a likely significant difference statistically. So we're going to go one step further and do a t-test to validate that. So what I'm going to do is open up, I'll open up in Safari. Alright, so in Safari, I'm going to go to graphpad.com. Down here in GraphPad Quick Calcs, these are the free ones. I'm looking for the t-test, so that's right here. I'm going to click on continuous data and continue. I want t-test to compare two means. And because I'm doing a paired t-test, I'm actually going to enter the data. But if you were doing an unpaired t-test, for example, the shell data, you could actually click on enter mean, standard deviation, and n, which, the mean is what you've already calculated in Excel. You've already calculated standard deviations, and the n is the number of trials. So if you have the shell data with crabs as one label, without crabs as the other, find the mean values, the standard deviations for each data set, and the number of trials in each data set. You could do that. Make sure you've got this unpaired t-test, and hit calculate now, and it'll do that number. But I don't have that, so I have a paired test. So I'm going to do it the long way, which you could do for paired or unpaired. Okay. So I need to enter my data here. So I'm going to relabel this column before and this one after. I'm going to, here's a short, I'm going to select those, copy that, and then open up my Safari, paste into that. So now I have them all visible. I'm going to do 12, 14, 23, and 11. And then delete all of that. But if you set it up this way, where you can still see it from behind, you can just type them straight in. So 27, 27, that's 75, 78, 83, 25, and 43. Okay, so I got all my data in there. I've got, I want a paired t-test because I've got before and after. So this 5 and 75 represents one individual's data before exercise and after exercise, or whatever it is, before treatment, after treatment. And then I'm going to hit calculate now. And what it gives me is a two-tailed p-value of 0.0237, which, which is quite interesting. We've got a t-value of 3.5526. Notice the degrees of freedom does not match what our textbook uses, so use what the textbook formula is. There's just a different way of calculating degrees of freedom. Use the textbook, that's the IB approved way. And here it says, by convention, this difference is considered to be statistically significant. So using this calculated t-value plus, let's see what's down here, nope, plus the correct degrees of freedom. You can use the t-table in your textbook to figure out if there's significance or not, but this tells you that it's statistically significant. Another way to know is that this p-value is 0.0237. Remember that we're looking for 95% confidence, which correlates to a p-value of 0.05, 5%. So if the calculated p-value is less than that 5% or 0.05, there is statistical significance. So 0.0237 is less than 0.05, therefore it's statistically significant, okay? And so this might be a value you want to put into your Word document or whatever word processor you have. You want to take this calculated t-value, the correct degrees of freedom, and the t-table value so that you can compare them as part of the conclusions to your lab, okay? And that wraps it up. I hope that helps.